Hello, this is Steve Cowles with AEM Test. Welcome to the inaugural episode of our Tech Talk Tuesdays series. Today's topic will be covering PoE testing. Get the facts. So we're going to cover a few different things today. We're going to talk about PoE, what the importance is of resistance when it comes to PoE. We'll talk about some other measurements that you can use for PoE. And what all this stuff means. So is it going to mean that your PoE is going to work 100%? Are there other things that you need to do? Again, this is the first in the series, so we're going to have one of these right now. The plan is every Tuesday. You'll be able to tune in and we'll be discussing different topics. And we'll probably have some guests from time to time as well. So let's get right into it with regard to PoE testing. So there are a couple of different things that you can test. Now, everybody's familiar with certification for 5E or 6 or 6A. There's also some things that are optional in the standards. They're not required for a sort of pre-qualification for power over Ethernet. And that's specifically DC resistive unbalance. So we all know that loop resistance for that link or that channel is part of your certification test. And we have a limit of 25 ohms or less for that loop resistance. And the other resistance values that are important when it comes to PoE are the resistance unbalance. And we'll dive into those a little bit in detail as we're running these tests. But essentially we want to make sure we have truly balanced pairs when it comes to resistance so that it doesn't create problems for our PoE. And this test is an important test. But it is not a PoE test, and some will refer to DCR or DC resistance test as a PoE test. It is not a PoE test. It is a pre-qualification. It's letting you know that when you certify your cable, it should perform fine for power over Ethernet, but it is not considered a PoE test. So I'll show you an example here. I'm going to go ahead and share my screen, and I've got my my Test Pro set up here. And we've got it in cable certification mode, and I'm going to go ahead, and you'll notice I've got on the left of your screen here is the main unit, and what you see on camera down here on the right is my remote. So what I'm going to do, I've got a link over here I'm going to plug into, and nice functionality of the Test Pro that you'll notice is that simultaneously both ends of this link see the wire map. So this is important for the technicians because if there is a wire map problem, you'll know about it right away. You don't have to wait to figure out and run a test or hit a button or anything else. You instantly get a live wire map. There was a little bit of delay you'll see on the display that I've got VNC'd onto my screen here. That's simply the VNC viewer, but in the real world, these both appear simultaneously. And it allows the technicians, if there is a problem with the wire map, to click on that wire map from either end and do a diagnostic to determine how far a short or an open or other type of event is from their specific location. It's relative to where you are on that link at the main or at the remote. So what we're going to do, we're just going to run a simple test here. We're just going to do a Cat6a test. I've already set this up. Cat6a test will run in 6 seconds. And in this 6 seconds, we're going to include, remember we're talking about that DC resistance when it comes to PoE. So we're going to look at the details tab here. And right here for DC resistance, we'll see in this test, we've got our loop resistance, and then we can see our unbalanced in pairs. And then we can see our unbalanced pair-to-pair. So these unbalanced numbers are the numbers that we're talking about when it comes to the PoE. And this is what we want to look at for that, that pre-qualification, if you will. So how do we set it up? Because right now they just had that little blue eye next to them, which means it's telling us that it's giving it to us for informational purposes. And we can look at it and see the limits and know that, yes, it's okay. But if we want to pass-fail for that DC resistance, we need to change our test limit from a regular Cat6a channel test here, and we're going to go into our project, and we're going to edit, and we're going to go into channel, and then we're going to choose, instead of Cat6a, we're going to choose Cat6a channel plus plus. And what that's going to do, it's going to give us the DC resistance unbalance. It's also going to give us some other parameters, TCL and ELTCTL for pass-fail. But the ones we're mainly concerned with right now are going to be the DC resistive unbalance. And then we'll just run this test again. And still, it's only going to take us 6 seconds. Most of your certification testers are going to have the capability to run a test. They might call it a plus plus like we do. They may call it something else as a suffix to the regular Cat6a test, but they will typically do this. Certifiers, in most cases, will typically do this DC resistive unbalance test. So we're going to go into the details. We're going to look at DC resistance, and here we see loop, and then we see the unbalance in pair, and we see the unbalance pair to pair. So everything passed here. These are good, but let's talk a little bit about the importance of this. So when it comes to power over Ethernet, delivering power, resistance can have a big impact on power. And I'm not going to pull up the Ohm's law diagram or anything, but essentially boiled down, Ohm's law will tell you that if the resistance is higher, you're going to have less power at that far end, less power delivered at the far end. So the lower resistance, the better flow you have, the better the power condition is going to be at the far end. So you want to keep that resistance as low as possible. And that's what our loop resistance is. And then it comes to the unbalance in pair and the unbalance pair to pair. Where this becomes super critical for power over Ethernet is that if you have an unbalance in these pairs, the power being delivered, it's being split between these pairs. So an 802.3 BT is using all 4 pairs, an AT is going to use only 2 pairs. So in the case of 2 pairs, let's say it's 1 and 2 and 3 and 6, you're only concerned about the unbalance in those 2 pairs. We're going to measure all 4. But when it comes to 4 pair for your BT, your 60 watt, 100 watt power, or 60 watt and 90 watt, depending on how you refer to it, you're concerned with all 4 pairs. So we've got to look at that unbalance in the pair. But then we get to unbalance in pair to pair. So what we're looking at in unbalance in pair to pair is we compare each pair to all 3 other pairs. So you've got an additional 6 measurements here. Versus if we were just doing a 2 pair, all you're comparing, if we had 1, 2, 3, and 6, you're just comparing 1 measurement right here for that AT. But when it gets to the higher power for that BT, we've got to look at all 4 pairs in every possible combination. So we look at that as part of our unbalanced pair-to-pair measurement. So that's a total of 6 tests for pair-to-pair and 4 measurements here for the in-pair. Whereas, so that's 10 versus 3 measurements that we're really concerned with for the 2 pair variety. So that's what it boils down to with the unbalanced in pair and the unbalanced pair to pair. And if you have an unbalance, what can happen is because of that skew, if you will, in the power delivery, you're going to have issues with your PoE. First off, your delivered power is going to be problematic. It may impact the data that's traveling on your cable, so you may have issues with your network. Additionally, you can also have issues with cable heating up. So there are a lot of things to be concerned about when it comes to the DC resistance unbalance. And again, DC resistance unbalance, this is not really a PoE test. It is a test. It's a resistance test. But it's not a PoE test because there's no PoE present when we run this test. So in order to test PoE, you actually have to have PoE present. So we'll talk about that a little bit as well. So what I'll do now is I'm going to replace a patch cord on one of these, and we'll see how it fares in our DC resistance unbalance test. We already passed with 1 cord. So let me unplug my remote. And we'll just swap out this patch cord. And let's see how this patch cord does with our DC resistance unbalance. I'll just back out of that test. And I'm going to hit auto test. And we'll see if this patch cord will still allow us to pass. So in this case, this failed. So when you're looking at your channel, and when we get into the PoE, the real PoE test here in a moment, we're going to talk about the impact of these patch cords and how you can troubleshoot and figure out what's causing a PoE issue. So you can determine, you know, is it my device that's malfunctioning? Is it something with the cable? Is it something with the switch? How the switch is set up or provisioned? So you know, this one we failed. And if we go look at our details, we look at DC resistance, and sure enough, the unbalanced in pair is beyond the limit, as well as the pair-to-pair. So this is an important thing to remember, because patch cords can have a detrimental effect, especially on shorter PoE links. So if you had say you have a 7 meter, or I'm sorry, not a 7 meter, a 2 meter patch cord, a 7-foot patch cord, and your overall link, maybe it's a short link, maybe it's only 30 feet. So now that 7-foot patch cord is a significant part of your overall channel, and if it's got unbalance, it can cause an issue with that that particular link. So what we're going to do now, I'm going to put the good cables back in, and we're going to switch to a real PoE test here. So I'm going to back out of this, and what we're going to do is switch our main unit. And we're going to go into a PoE test mode, and we're going to take my remote unit, and what I'm going to do is run on my remote, go into a PoE injector. So I'm going to use my remote as a switch, if you will, at the other end, so I can have a 10 gig connection. And then I'm going to connect my my main unit to the other end of that. So we need to go to the injector. So I'm connected into my injector, and now I'm going to connect to my link, and I'm hooked up. And now we see we've got PoE present. So I've got PoE, and we can see on the display here, we've got 56 volts. We've got PSE type 4, PD class 8. We see we've got PoE on all 4 pairs, and we've got 71 watts. Now, a word about the 71 watts. 71 watts is the theoretical power delivery at the end of a 100 meter link that is perfectly functioning. So that's what we should be able to get at the end of a 100 meter link. Now, the cables that we've got in here right now are the cables that were connected when we ran the pre-qualification test. So we passed the 6A++, so we pre-qualified that cable for PoE. And again, some may call that a PoE test, but it's not really. So what we're going to do now is we need to put load on this. Now in this test, I can choose from a variety of PoE types. I can choose AT, AF, BT. I can choose UPoE. I'm going to leave this at the 90 watt BT. When you first connect, if you don't have, if I have this set for BT and BT is not present, it's going to let you know what is present. So it'll show you if I connect it to something that's only capable of a PSE type. If it's PSE type 2, it'll show up. So that'll automatically negotiate here. So the 71 watts is what the switch is telling us it's going to give us. So how do we know what we can get from that switch? We need to put a load on this. So what we're going to do is go ahead and hit this load button right here. And we see we're not getting 71 watts. We're getting 67 watts. And this particular cable run is maybe half of the 100 meter length that theoretical maximum of 71 watts could be delivered. So this link is not perfect for PoE. It passed, but it is not perfect. So we're not getting the 71 watts. Now, the question is, will the 67 be enough for my device? Probably. It really depends on that device. What you're really looking for here when you run a load test is some significant difference here. So if you were expecting that 71 or something close to that range, and you're getting something really, really low, approaching 50 watts or worse, you probably have some troubleshooting to do. So what you would do is you would take this this tool. And right now, again, I have this hooked up with my Test Pro remote on the far end, but a typical application, you'll have a switch with PoE rather than me running my Test Pro through the PoE injector. You'd have a switch with a PoE port on it that you're testing from the device back to the switch to troubleshoot a problem. So you determine that you're not getting the adequate power. You'll take this back into the closet. You can check into the switch port and see if you're actually getting the power that you need at the switch port. Maybe the switch port is not provisioned properly. Maybe it's maybe an end user purchased a 90 watt 12 port PoE switch for $50, and you're going to get what you pay for. 90 watt 12 port switch for $50 is not going to be 90 watts per port. So maybe they got enough power when they plugged their first PoE device in, and as they started to add more devices, they can't operate the devices. So a lot of things could happen. The other thing, remember earlier we mentioned patch cords. So maybe somebody lost a patch cord, or they damaged a patch cord that was connecting the switch to the link, the patch panel. And they just replaced it with any old patch cable and decided that they wanted to just use that. And now they're having problems with their PoE. You can see a difference when the patch cord is changed out. So what I'll do is I'll disconnect from my my cable that's going from my injector to my panel. And we're going to substitute that cable that we tested earlier. And we're just going to plug into the injector. And then we'll plug into our port on the panel. And then I'm just going to refresh this. And remember, we had 67.14, 67.01. Not a big difference on this one. So this cable, even though it failed, caused a resistance unbalance fail, it doesn't make a huge difference between what we get in the PoE test versus what we get with the good cable. Now, I'm going to throw a wild card in here. Some of you may have seen these. If you've been around as long as I have, you've seen the silver satin cables. Nobody in their right mind would use this for PoE, right? But for giggles, let's take a look and see what happens when we do this. We're going to refresh. We're at 61 watts. We just dropped 6 watts. So we went down to 61 watts. Now, beyond that, there's going to be all kinds of other problems with this running PoE over silver satin, obviously. So we wouldn't want to do it. We're going to get a lot of issues with the network, a lot of crosstalk issues, a lot of SNR issues. So we certainly wouldn't want to do that. So beyond this test, beyond the PoE test, I'm going to hook back up to my injector here. Go back to our good cables. And beyond just troubleshooting the PoE, you probably also want to look at how that link is performing. So imagine we're testing back into a switch. It'd be the same process as what I've got going on into my unit here. So you could do an end-to-end test like this with the 2 Test Pros, but more often you would do it with a switch on the far end. You're just connecting where the powered device is and testing back into the switch. And what we're going to do is run a test measuring the SNR values and the different multi-gig speeds. And I'm going to, for the sake of time, I'm going to adjust my test limit and not run the 10 gig. We'll just run up to 5. That'll speed up the test process a little bit. And what we're going to do, I'm going to start this test and I'll explain what this test will do for us. So we're going to run an auto test. Now, this is not a certification test. This is a test of the network link. It's going to, under traffic load and under PoE load, you'll see when the test is done, we'll have a PoE load test. So we're putting PoE load on, we're running traffic, so we're putting traffic load on, and we're measuring the signal to noise ratio over this link. And we want to look at the link, and we're going to do a connection test. So we're going to check it at 100 meg and 1 gig, make sure we can connect okay. We're going to do the same thing at 2.5 gig. And we're going to do the same thing at 5 gig. And if we'd selected 10 gig, we'd move on and do the same thing at 10. At the same time, again, with that traffic load, we're doing an SNR test at 2.5, at 5, and then if we had selected it at 10 gig. And what an SNR test is, it's signal to noise ratio. So while we're running traffic, we're actually looking at how much noise is impacting that traffic on the cable. And when we see SNR values, we want to look at these numbers right here. The lower the number, the more problems you're likely to have. A good rule of thumb, if you've got a 3.0 or better, you're probably okay. You definitely want to stay away from any SNR numbers that approach 0. If you do have an issue with any of your SNR numbers, you can actually look at it by pair, so you can see if which pair is the worst case, and then you can kind of go back to your normal physical cable troubleshooting processes if you do have an issue there. So we've got our SNR values. We see we've connected at the selected speeds. We see that we're good at 1 gig and 100 meg for connection. You can also run an SNR for those lower speeds through the side port if you needed to. Then we're going to look at PoE. So here we've got that PoE test. We've got 67 watts, and we'll save this test as part of our saved test results. So no longer is your certifier just a certifier. It goes way beyond being a certifier when you have this capability now. So you've got the ability to run that certification test, that Cat6a, that plus test. So you're testing the TCL, the ELTCL, ELTCTL, and the DC resistance on balance, which is the latter one, important PoE. You've got that as your certification test, but once the network equipment is installed, you run this test on all those same links. You can actually have some more value-added documentation that your network is in good shape, what your PoE performance looks like, what your SNR values are, because a lot of things change from the time that you install it to the time everything is turned up, everything is in the building. Other equipment not related to your data networks might be in the building that's generating noise. Any number of things can impact that performance. So this is this would be the other test beyond troubleshooting the PoE. And then we could do the same thing. We could run if we ran this test with the silver satin, obviously it's going to fail. If we have a lesser grade patch cord, it would fail. But your first troubleshooting when you're having that PoE issue again comes back to that PoE tool where you're doing a real PoE test on that cable. So that will allow you to go beyond simply pre-qualifying the cable at the time that you certify it. So it looks like we've got a few minutes left here. I think we can go to a couple of questions. Let me take a look here. Looks like a few of them have come in, and I'll keep my screen up here in case I have to share anything. Let's see, we have a question that came in about how the power is divided in all the ports. Can I manage the power budget in each port? So that's more of a switch question. Typically, your managed switches are going to let you allocate what you want per port. You would consult your switch documentation for that, but typically you would be able to do that. Let's see. Got a question here. What should the limit be? I'm not sure which limit that refers to. If it's referring to the SNR value, a rule of thumb for that is going to be 3 dB. A good way to look at that is every network is going to be different. So if you have a network that's functioning perfectly and you run an SNR test on it and everything on there is showing up at 6 or 7 dB, then that needs to be your benchmark, because maybe you want that to be your bottom line. But 3 dB, once it starts getting below that, the closer you get to 0, the more issues you're likely to have. That was the limit questions related to DCR. Okay, good question. So the limit for DCR, I will show you that. Let me bring that up real quick. And so these are laid out by the standards. So for DC loop resistance, these are your limits. So again, I mentioned loop resistance. It's going to be 25 ohms. The DC resistance on balance, it's less than 3% for unbalanced in pair, and less than 7% of your balance between pairs, and that's defined by the standards. And you don't have to worry about doing the math for all this. The tester has that all built into it. So any of these certifiers that do this will measure this, and they'll compare it. They know what the percentages are. And this kind of this slide will drive home a little bit what we talked about earlier when I was showing you the live screen. So what makes it really important, again, is that when it comes to the higher power, 60 watts and above, your BT PoE, is that we've got all these various combinations. So, we've got to look at all 4 pairs, but then we're looking at the pair-to-pair. There's 6 different combinations here. So it gets much more complicated than when we're just looking at a 2-pair variety of the PoE. Let's see what other questions we've got here. Jeff Bowser, is there a difference in testing PoE with between, mid, or end span PoE devices? So this PoE test is going to be the same no matter where you're testing it. You're going to have that expected power delivery at the endpoint. So we'd be testing it at the endpoint, or you'd go back and then test it at that mid-span device to determine that mid-span device is giving you the power at that point. So that would be the only difference. The measurements are still going to be the same. Let's see, we have another question. What does it mean if DC resistance fails on a PoE test? So, okay, so I think what you mean there is if your DC resistance fails, because that's not really a PoE test, DC resistance isn't a test, what does it mean to the PoE if that resistance fails when you actually look at a PoE test? And in that case, you would probably see a reduction in the power delivered at the endpoint. If we're referring to what could cause that resistance unbalance, it could be the quality of the cable. It could be termination practices, which would also typically lead to other components of the overall Cat6a test failing. So, for instance, if you at the point of termination, for whatever reason, you had an extra couple inches of pair 1 versus pair 2 versus pair 3 versus pair 4, for whatever reason you made each of these a different length before you terminated them, that would be a little bizarre, but it would cause some differences in resistance. Issues with the cabling itself during manufacture, during installation, can cause resistance issues. So a good example of something that can affect resistance is excess pulling tension. So if you pull a cable too hard, you can change the geometry of the cable, and you can alter that copper conductor to the point where that resistance value will change, and it might change on one pair and not another. So any number of things could impact that. Let's see, what else do we have here? We've got what's better for PoE, 24 gauge or 23 gauge? So that's a very good question. So when it comes to the wire size, 24 gauge versus 23 gauge, 24 gauge is a smaller diameter conductor than the 23 gauge. 23 gauge is a heavier copper. Just remembering that the lower the number, the thicker that conductor is, and the thicker conductor, a heavier cable, is going to have a lower resistance. So what that means is you'll get better power delivery because you've got less resistance. So that resistance affects that flow of electrons, if you will, over the cable. So it's going to impact that power delivery. So that will affect that PoE delivery. So 23 gauge would definitely be better if you're choosing between a 24 and a 23 of the same category of cable. Why does the patch cord matter so much for PoE? Again, I think I mentioned that earlier. If the patch cord, especially on a short link, it could be a large percentage of the overall channel, and that will impact that. What happens if my test pro is set for 90 watt and I connect to a lower PoE type? I also think I covered that. Maybe that came in before, but it will detect that lower PoE type when you connect, even if you're set for that. So let's see, what else? Do we have a best practice document share for testing PoE? And Lisa shared that one with me. Yeah, and it is on our blog. So We've got another question coming in. So if you go to the aem-test.com, we have a blog there, and you can look up that blog, and you'll see that PoE testing guideline on there. Is there a temperature test in cables for PoE, since temperature might affect performance? So there's not a temperature test in the certifiers. So they're not really measuring the temperature of the cable. I'm not sure if there's a temperature test out there or not. I might have to ping my friend Chuck Bowser. He may have come across something in his experience out there. But we don't have anything in the certifier that actually will do a temperature test. And let's see here. Let's see. I think we've come to about the end of our questions, and we're right at our 30 minutes. So I'd like to thank everybody for joining in today, and please look at the website again, and you'll see the if you go to www.aem-test.com/ttws, you'll see our upcoming episodes. We'll always have the next 4 episodes listed on there, so you'll know what's coming up, and pick the ones or pick all of them that you want to attend, and we look forward to having everybody as part of these sessions. Thanks again, and everybody have a great day.